Hello, this is Kevin from MemSQL, and thanks to everyone who has joined. Today we're going to be talking about securing your real-time data, and I'm pleased to have Rick Negrin, who's MemSQL Product Manager, talking about how MemSQL can help secure your real-time data. Today's webcast will be recorded, and we'll follow up with the recording within 24 to 48 hours of finishing up here. If you have any questions throughout the webcast, please enter them through the GoToWebinar question panel, and we'll have about 15 minutes at the end here to field any questions that come through. So with that, I'll hand it over to Rick to provide a presentation and demo. Rick?
Thank you, Kevin. Like Kevin said, my name is Rick Negrin. I'm a product manager here at MemSQL, working on security among other parts of the product as well. And today we'll be talking about securing your real-time data. So the world is moving faster. Expectations of customers, as well as investors and partners, are higher than they've ever been for companies to respond. Respond to orders, questions, competitive threats, external world events, anything that's happening in your market. And companies are becoming more data-driven because of this. You see ones like Facebook and Google that have really pioneered the advantages of using data to make decisions in real time, watching customers as they use their products. And you see this not just in tech, but across all the industries. As more and more data is collected at the edges of the system and brought back into headquarters. And the thing is, it's not just the few data analysts that are expected to make use of that data. All the employees now are expected to use that data effectively and make well-informed decisions as quickly as possible. But the bottleneck is not the data. Like, we do not have a data scarcity problem. In fact, it's the opposite. Data generation is exploding in the enterprise. Employees are wrestling with how to consume it and how to get insight from it. So we have the data is growing, the set of users using the data is growing, and the speed with which data is flowing is growing. And the only thing shrinking is the amount of time you have to respond. And the current data platforms that are out there are not able to handle all these requirements, especially as your business scales. And so what's needed is a data platform that can bring in data very quickly, support high levels of users concurrently trying to get to the data, and a way to quickly get the data to get out answers to the questions that they're asking. Now, if that wasn't hard enough, you still have to worry about securing your data. And with the data moving faster and getting bigger and more people accessing the data, the platform requirements for security get more complicated. So there's 5 key things to look at when you're evaluating security and how to secure your data. One would be data in transit, which is about data that's flowing on the network. And that's funny because when I sit and talk to customers about their data systems, we often draw a single box on the whiteboard and talk about it as if it's a standalone system that is the only system that exists in the company. But the reality is, anyone who's worked in the field knows, is that there's many systems, and those systems are all connected, and data is constantly flowing over the network. And with so many modern applications built on distributed systems, the diagram gets even more complicated. So it's imperative that the data flowing on the network is protected at all the right points. And then you manage that protection and trade it off against performance and the consequences of doing that. The second key point is data at rest. So once the data is landed somewhere, it needs to be protected there as well. Encryption is the key part of that strategy to make sure only the right people have access to the data, regardless of what level of the system they're looking at. Third is authentication. Now, authentication may seem simple, right? Identify who the person is and have them put in a username and password. But as more and more systems get put into place, and more users, some of whom are in the company, some of whom may not be in the company, keeping track of who's connecting and verifying who they are gets tricky. The days of every system, creating a separate username and password and making the users manage all those usernames and passwords, and then keeping track of which ones you've given out and who has them, those days are over. It can't take weeks to get an account. We just can't have that many things floating around. You really need to have a single identity for each user that can be used across systems in order to manage it effectively. And then there's not just who the person is and whether they can see the data, but how much of the data can they see? Because not everyone gets to see all of the data. And sometimes users are allowed to see parts of it, sometimes they're allowed to manipulate or read it but not manipulate it, and some are allowed to even manipulate the infrastructure. So keeping track of all these pieces at the data level, an item data level, it's just too difficult to manage. And this is by far one of the hardest things to deal with because it has so many pieces. The amount of data and the granularity of the item data is so huge, along with the fact that it involves human workflow. Someone has to approve the access. And on top of that, it's changing all the time. People are coming and going into the group and out of the group and in the company and out of the company. And so these things need to be constantly changing. And as you change your security mechanisms, you're adjusting the permissions that are allowed for any given group to access any given data. So with all that change and all that volume, companies need a higher level abstraction in order to govern access to data effectively. And last but not least is the security policy. Because the weakest link in security is not the technology, it's the people. No matter how good your technology is, if the people aren't using it correctly, you'll have vulnerabilities. And so it's important to have the right kind of policies and a way to enforce those policies so that they get used correctly. And for all those reasons, it was the motivation for why we built MemSQL. And MemSQL is a database platform for real-time analytics that meets all of those requirements that we're just talking about. It's real-time, meaning it can handle large amounts of data being ingested or put into the system, think millions of rows per second. It can query the system and get the answers back very, very quickly. And it can support lots of users or applications concurrently using the system. It's also scalable. Even though it's a relational database, the way you think of SQL, Oracle, or any other relational database, but one of our key differences is that it's scalable. It's a horizontal scale-out system. So if you need more power, you just add more nodes to the system, and it scales linearly. It also we're a software vendor, so we provide our software that you can run on premises, or you can run it yourself in any cloud, both AWS as well as Amazon and Google, or anywhere you want to run the software. And in addition, we've recently launched our managed cloud service. So if you don't want to run the software, we'll run it for you, and you can just put your data in and query it out. And of course, like any mission-critical system, it has high availability features and a whole bunch of security that we'll talk about in a minute. And lastly, it uses a proven relational model. So it's a true relational system. It supports ANSI SQL with the full join syntax. It's transactional, so you get ASCII compliance. And we are compatible, wire compatible with MySQL, which means that you get the entire ecosystem that supports MySQL. So in terms of what this looks like, it's basically a clustered system. So it's a set of computers all running the MemSQL software, all working together to store your data and allow you to run queries. But from the outside, it looks like a single database. So when you connect to it, it looks like a database you can connect to and run queries, but under the covers, that information is distributed and the queries are harnessing the power of all the machines. Now we have a couple of different storage engines. We have a high volume transaction, we call it the row store engine, as well as an OLAP engine or a column store engine for doing fast, scalable SQL analytics. And then we have a mechanism we call pipelines that lets you ingest data in real time and stream it in to the system as well. Now MemSQL, to understand how it fits in the larger ecosystem, think of it as the place you land data and the place you query data. And so you can pull data from places like Kafka or Kinesis or any of the queuing products. You can use transformations, you can use Spark or SAS or any of the transformation engines that are out there. And you can also pull from other data stores like Amazon S3 or SQL or Oracle or MySQL. And on the right side, to get data out, you can either use the standard BI tools, and any BI tool that supports MySQL will work with MemSQL. But the ones that work particularly well are Tableau, Zoom Data Looker, MicroStrategy Click, and many more. Or if you want to build your own custom application, you can build a dashboard or even build an application that does operational analytics pulling from MemSQL. So let me give you an example of a company that's using MemSQL to achieve all these requirements. So Pinterest, I'm going to assume that most of you have heard of Pinterest and know what they do. Had this need where they had millions of people dropping pins all the time, and they wanted to get an understanding of who's dropping the pins, what kind of pins are they dropping, where are they geographically located, and use that analytics to better understand their business, better make changes to their site, and eventually serve up ads, targeted ads for the customers. So that meant that they needed to take all of that data, analyze it very, very quickly, think in seconds, and be able to make choices and serve up information in a matter of seconds. And so they're ingesting about 1 gigabyte per second, which works out to about 72 terabytes a day. It's a lot of data. And then doing the computation, doing the analysis on that data on the fly, and then outputting the results. And then you can see they're using a combination of Kafka and Spark to do that ingest and analysis. And then MemSQL for the database layer, and then they built their own custom operational dashboard. So showing massive amounts of data flowing in and a high concurrency of applications and users accessing the data. Another example is Comcast. So Comcast uses MemSQL for a couple of different things. They had the need of, obviously, millions of customers who are using their set-top boxes all the time. And they wanted to be able to track, one, when people are setting up the boxes, they want to be able to know in real time, hey, are anybody having difficulty setting up their set-top box? And if they do, they can reach out proactively and try to help them rather than waiting for them to get frustrated and make a call after they're already unhappy and disgruntled. Because, nobody is unhappy with Comcast or the service they offer. And they're really trying to improve their customer satisfaction. On top of that, once they're up and running, they also wanted to monitor the video playback, like the streaming video, to look for anomalies or problems so they could jump on them quickly and correct them before they were widespread or affecting too many people. And so they had millions of customers streaming data in all the time about the status of their machines, and they do real-time monitoring and be able to respond very quickly. And they used MemSQL for this and got excellent results. So that's the high level. So let's drill in a little bit to, because this talk is focused on security, on some of the security features that MemSQL offers and that make it possible to secure your data well. So for network encryption, MemSQL supports SSL or TLS. It supports all the versions of TLS, TLS 1, 1.1, and 1.2. And so you can secure the data when you're connecting to MemSQL from your client, and also within the cluster if you desire as well. MemSQL also runs equally well if you need to encrypt the data. You can encrypt the disk underneath it, and MemSQL will run on top of that encrypted disk, allowing the data to be encrypted at rest. To solve the identity problem, MemSQL supports Kerberos as well as PAM, which is the pluggable authentication model built into Linux. So if you have Linux users who wanted to reuse their identity, you can leverage those to use as MemSQL ID users, as well as using Kerberos identity system. For access control, MemSQL implemented something called role-based access control. This allows you to create roles and groups, and then assign permissions to the roles, and then put users and groups and bind roles and groups together. And I'll do a demo on this in just a few minutes to give you more details on what that looks like. And lastly, we have a password policy as a mechanism for enforcing that people have strong and good passwords. Great, and so now we'll go to the fun part where I'll do a demo. So for the demo, I'm going to do two things. One is I want to show you some of the speeds you can get with MemSQL with a real cluster running live using one of our speed tests. And then I'll show you an example of how role-based access control works. So what I have here is the ops UI, the operations UI for MemSQL. It is used for a variety of things, primarily to understand the state of the system. You can see I have a cluster here with 8 nodes. And it shows you the CPU and memory and what's going in the system. So you can see right now not much is going on. So what I'm going to do is I'm going to run something we call a speed test, where it basically will insert a whole bunch of rows using this insert statement, insert into DB test table. It's just a 2-column table, and it just does it's doing inserts. And you can see it's already inserted 35 million rows. And at the same time, it's continuing to do select statements from that table doing a group by. And you can see, if I look at the cluster, if the bars fill in, the CPU and memory and the network are quite active as all these inserts and queries are going on. and the speed test finished, and it inserted 100 million rows. It was in parallel. It was also reading 600. It was able to do 622 million reads with an average of about 3.5 million inserts per second. And this is on a basic 8-node cluster using the M4X large Amazon machine. So on a relatively lightweight cluster, we're able to get 3.5 million inserts per second. So I think it's pretty powerful, pretty good. And you're able to read 600 million rows while you're inserting that data. Now let me show you what role-based access control looks like. So what we have is a database, a MemSQL database that I created already called the security demo database. And I'm going to log into it as the root user. And to tee up the scenario, what I'm going to do, imagine that you have the security demo database and you wanted to create two roles. One is the user who is going to manage the database, so he should have access to full control of the database, but not access anything else in the cluster. And then we want an application user that can be used in the application that just has access to query the data and insert data, but can't alter the schema or make any other changes. So the first thing we're going to do is we're going to create a role called the DBO role. And so it's just a simple syntax, create a role, DBO role, and now I'm going to grant it a set of permissions. I do that using the grant statement. And so you can see that I gave it permission to be able to drop the database, to select and insert and update rows, and to create and alter and drop tables and other SQL objects. So great, so now I have my DBO role, and I'm going to do the same thing for the app role. I created a role called app role, and it has select and insert and update permissions, some show view permissions, as well as a few other things, but it doesn't have the ability to create tables, for example, or alter the schema in any way. So now I've got two roles, but that in itself doesn't help me yet. So first, the next step I need to do is create the group. So I'm going to create the app group by saying create group and app group, and I'm going to create the DBO group. Now I have the groups and I have the roles. And then here's the magic. Now I say grant app role to app group. And grant the DBO role to the DBO group. And what this does is it says, for all the users who are in these groups, in the app group, give them the permissions of the DBO role. And same thing for the app group to the app role. Now I don't have any users in those groups, so let's create a user and we'll put them in the group. You can see here it's grant usage on DBO user. This is the MySQL syntax for creating a user, and we use the MySQL syntax. You can also say create user, which would work as well. So it creates a user, and then I grant that, and then I put that user into the DBO group. And because that group has the DBO role permissions, now DBO user therefore has the permissions of DBO role. And I'm going to do the same thing for the app user. I create the app user, and then I put the app user into the app group. And everything's looking great. And that's how you set up role-based access control. But just in case you don't believe me that this actually works, let's actually test it out. Now, what you can see is I logged out of MemSQL, and then I logged back in, and I did two things. I logged back in directly to the security demo database, and I logged in as the DBO user. Normally, right. So I'm logged in as user, and so just to show you there's nothing up my sleeve, I'll select the current user, make sure that, and yes, I'm logged in as the DBO user. Now, as a DBO user, right, I can say show databases, but it only shows me the security demo and information schema. I can't see the other databases in the cluster. Now, I am able to create a table, right, because I have the create permission. That works fine. And I can insert into the table, the instance rows, and I can select from the table. And you can see the rows I selected. So I'm clearly the master of this database. I'm the database owner, and I'm able to do all the things I need to be able to do. But I can't affect anything outside the cluster. Okay, that's half the story. Now let's log in as the app user and see what he can do. You can see I've logged in again to the security demo database, and I'm now logged in as the app user. So I'm going to try to create another table. And when I try to create a table, I get a command denied because I don't have permissions to create a table as this user. So RBAC is preventing me from doing something I'm not supposed to be able to do. But I can insert into the table that is already there, and I can select from it, which are the things I'm allowed to do. One, and I can see the rows that were in there, that were inserted before, plus the row that I inserted. And so that gives you a demonstration of how you can create roles and create groups, bind them together, but manage them separately. So if I were to, for example, decide, well, the DBO owner should have one other permission, I simply go add that permission and grant it to the role, and all of the people who are in the group that's bound to that role automatically get those permissions without having to remember who's got what. And if I get another person, say, who shows up with the company and needs access as an app user, I simply add them to the group, the app group. And then they get all the right permissions without having to think about, okay, what are the permissions this person's supposed to have? And so by being able to manage those two things independently, it makes it much easier to manage security at a more abstract and a higher level. Let's go back to our deck. So let me just finish up by talking about how you can get MemSQL if you haven't already played with it. We have a community edition that's free forever. Just has it has unlimited capacity and scale, and pretty much has all the features you need to play with, except for some of the HA and security features. If you want to play with those, you can download our enterprise free trial, and it has all those other pieces, the security and HA. And then, as I mentioned, we just recently launched our managed cloud service, which is the same MemSQL software, but where MemSQL does the cluster management for you, runs on AWS, and allows you to ingest data from S3 and Kinesis and so on. We're currently in a private beta, but will be more broadly available later in 2017. And so if you're interested, there's a sign-up page you can get to on memsql.com. And that's it. Thank you.
Great. Thanks so much, Rick. And for all of those that are on the webcast that have any questions, now's the time to ask them. So if you can just plug in any questions you may have in the GoToWebinar question panel, I'll field them as they come in, or Rick, I'll ask them and Rick can field them. We did have a few that came through during the course of the webcast. One of which is, are all the features discussed in this presentation now currently available with MemSQL?
Yes, so all the stuff I talked about in this deck are all available in MemSQL today. We do, yeah.
Great, and then does MemSQL offer the same security features on-prem and as well as in the cloud offering?
For the most part. So things like role-based access control and TLS, the SSL are all offered. Things like Kerberos are not there yet, but will be eventually. So the plan is to have complete symmetry between on-prem and cloud. But during the beta, there'll be some gaps.
Cool. And then another question on MemSQL as just a database platform in general. Is it SQL on Hadoop? Is it a NoSQL database? Can you dive into that a little bit, Rick?
Sure. So MemSQL is a relational database, the same way you think about Oracle or SQL Server or MySQL or Postgres. It's a full-on relational database with transactions and ACID and all the things you would expect. So it's not NoSQL and separate from and it has its own distributed management system, so it doesn't run on any of the Hadoop ecosystem. But it does connect and can pull data from or push data to Hadoop or any of the other NoSQL systems.
Great. And then a question on MemSQL being available in the AWS government cloud and security features around that.
Yeah. So we are working on being in the government cloud. There's different government clouds, but we're in the process of getting through the stages of making it available on all the government clouds.
Cool. And then just one last question is what features are coming out in the next year around security? Nothing specific there.
Yep. So we'll be supporting other identity providers or single sign-on systems besides Kerberos, things like SAML and maybe some other ones, as well as features like auditing, so you can keep track of who's making what changes in the system.
Cool. All right. Well, I think that does it as far as questions that came through. If anyone has any further questions, you can email info@memsql.com, and we will get back to you with an answer right away. We'll be following up in the next day or two with a recording of the webcast. And thanks, Rick, and everyone have a good one. Bye.
Thank you. Bye-bye.